Hi, everybody. Thanks for coming to our today presentation. We will talk about application integration on Yocto-based Linux. So we will talk about Linux, how you can enable a nice graphical interface on your system. And we will focus on this application layer, that means on top of your operating system. But how you build your operating system, how you build your application, how you to integrate everything in the proper way will be the key topic for today. I'm Pierre Gall. I'm a director of the Embedded Kit. And we, at the Embedded Kit, we aim to deliver technology to accelerate the development of Yocto-based system. And today, I'm really happy to be with Stefan from Yocto Group. Stefan, if you want to introduce yourself.
Yes, of course. Hello, my name is Stefan Joos. I'm a senior solutions engineer working for the Q company for over 6 years now. And I am in constant contact with our customers, and I will give you a brief overview of our embedded solutions when it comes to Qt.
What is important when you are building a new embedded system, a new device, you as OEM, you as device maker, is to be sure that the product will bring all the benefits you want to your customer. And in fact, all this added value of the benefits of your product will more or less come from two topics: the hardware first and the software. The hardware will bring sensors, will bring capabilities, will bring a feature itself. A coffee machine will make a coffee. And the application itself will allow you to bring functionalities, will bring customization, will bring a way to manage the features that the hardware is bringing. So at the end, the operating system is just a way to achieve that, but it's not the end goal. You can see here two examples of product. One is a coffee machine, one is off-highway control system, but we can give you hundreds of examples, even without sometimes without any screen. You have a lot of gateway application where the application is the core system that will ingest a protocol coming from an industrial bus, industrial field, and transfer that to another subsystem or to another cloud system. Application is the core value of your system. And today, we will talk about how to deploy it, how to package it, and which technology you can use for this one. Let's start with a few definitions. We will use a lot the word deploy or package. In fact, what does that mean? When you have some source code, you will have to create a bundle that will be build a binary version of your system, and you will have to send this build version, these build packages to your embedded system, to your embedded operating system. It's not only a matter of one application with one binary. It's also a problem of managing all the dependencies, and you will have to deploy a full package for for being able to run your application on your operating system. And in fact, it's more complex than that, because you have a lot of different contexts where you would like to deploy your application. And in each context, the deployment could be done differently. For example, if you are in development, you would like to be able to deploy easily without constraints, being able to remotely debug the system with a direct control from your development laptop to your target. If you are in test qualification, you would like to be in an area where you can easily update your system, you can easily get the logs and the debug information, but you want to be really close to the production environment. And at the end, for production, there is two sub cases. One is manufacturing. You would like to flash your system for manufacturing, so it has to be robust, it has to be secured, closed. And you also have the case where you would like to package it for update, which is a different way to package your system, because it will have to support migration of the system, being able to be compatible with the current online system. So there is a lot of different ways to package and to manage the deployment of this system. Now let's have a look on how you can do that. And today we will focus on Yocto, because in this embedded world, we at the Embedded Kit, but a lot of partners and companies in this world really trust about Yocto. for building this operating system. Why Yocto? In 2 words, just because of the level of customization you can bring to your operating system. And limiting the number of components, optimizing the system is really a key topic for optimization purpose, but also for cybersecurity purpose. That's not the meaning of the today conference. And there is a lot of other conference about cybersecurity, but least privilege, minimal image, reduce the surface, attack surface is really a key topic. But that will also bring you complexity, because if you remove all the components, your application development team will probably have reduced possibilities, or you will create dependency with your Yocto team and so on. So why building in Yocto? Because Yocto is a nice dependency manager. So you need some components, Yocto will bring the component you need. It will build the entire system in a real consistency model, and you will have no issue about the result. You will be sure that it will be something really clean. And the last added value of Yocto is it's really made for multi-configuration management. So if you have the same application, the same hardware, but you have different build options in regard of the range of your product you are building, you can do that very, very efficiently with Yocto, because Yocto is dependency manager and a build system. It will take the package, take all the configuration, make all the cross-check, and at the end, generate you a package which is fully well integrated into your system. What are the disadvantages of using Yocto for building your system? It's definitely not application development compliant, because usually the application team would like to add a new component, a new third party, and it will say, okay, we need this new curl library. Oh, it's not integrated into the Yocto. Okay, so that means we need to modify the Yocto. That's not really flexible. And the application team usually does not have the Yocto knowledge to make this modification. So there is a collaboration work. Collaboration is positive and good, but as soon as you need a new component, it's always a problem. So that's usually why application team prefer to use a Debian or an Ubuntu, just using a package manager, apt-get install. That's useful for the application team, but at the end, you have 4 GB images with a lot of vulnerabilities inside your system. So maybe there is different approach that you can use in the different contexts we have seen before. The one for development purpose, the one for production, the one for test. Just have a look on quickly how it works, this concept of building inside Yocto. On the next slide, you have Yocto that could enumerate all the meta layers of your system, including all the system meta layers, meta for the kernel, for all the Linux system, and you can create your own meta layers with the recipe to build your custom application. So the system will clone automatically the source code of your application, will build the application binary inside the nice context, the proper context, the good architecture, the good compiler, and at the end, integrate all of this file inside a package, because Yocto is a package manager, and integrate that inside your system. On the next slide, you will see that you can do, to simplify the life of the application development, a build of this application outside of the context, but still using the Yocto dedicated image you have generated. So Yocto can generate a toolchain that will include all the library, all the compilers of your system, and then this toolchain could be used on an external laptop for doing cross-compilation for the application development, transforming the application source code into a binary. And then the binary could be deployed manually for development purpose. What's happened next? If you need an extra component, for example, curl, but it's not integrated into the Yocto, you will need to add a new package inside Yocto that will generate a new toolchain that will be delivered to the application team that will be able to implement the new features. That's where it could be a problem. It could be more complex because it needs to generate a new package when you need a new toolchain, when you need a new package. In the last approach, you have also the capabilities with the next slide to integrate a new package directly inside your application source code. That's a different approach, a different way. So you keep your toolchain and you build your third-party libraries within your source code application. It's less simple because you don't need to modify the Yocto toolchain, but it's a different way to package and you have less control on what happens inside your system. So that's just for your information, different approach you can use for building your system. Let's make a step back and understand if there is different possibilities for doing this integration inside your system. And in fact, there is a lot of technology, a lot of possibilities to integrate your package and to ensure the quality. And the first consideration I would like to highlight is about containerization of your application. So till now, we have assumed that you take your binary, you put it inside your application, inside your Yocto, and at the end, it runs as a standard application inside your system. But it exists functionalities of containerization of application that now can be very easily implemented on an embedded system. If a few years ago, this containers approach was really dedicated for server and PC approach, now you can enable containers on an embedded system quite easily. A lot of different technology, Dockers, RunC, Nspawn, systemd Nspawn, all have added value and also bring some constraints. Be careful with containers. It brings interesting added value like isolation, but it brings isolation if you do that properly and you isolate different components in the right order. Because if at the end you enable the containers, but you map the graphical interface, you map the network interface, you map all the drivers, you map everything into your containers will not be so much a level of isolation to your system. So yes, to use containers, but for the good reason and with the proper organization and the proper configuration, just not enabling everything to make it simple. Because if you do that, it will not bring any added value anymore. So yes, you can think about containers. Containers could be a way to package and to deploy an update. But in embedded system, we don't see so much a way to deploy an update through container registry. And usually we see other approach with an update level, which could be at a partition level or at a file levels. But it exists some framework, some technology like SW Update or like Mender that are one of our partners. And you can enable a technology that will help you to update at the appropriate level your system. So a new way to package and to send a new application to your system. And last consideration I would like to highlight today, before giving the end to Stefan, is about automation. We have explained a lot of stuff about building Yocto, building your app, but please think about DevOps approach with a maximum of automation, because it will be really, really, really added value to being able to reproduce your system, to launch or run automated testing, to being able to ensure the code quality through this automation, and having a good process, a good DevOps process will bring you new quality. In the Embedded Kit, we have a tool dedicated to automation, like named Pluma, and we really trust GitLab. Today, we use a lot GitLab in our own development, and we recommend GitLab to our customer, but absolutely not mandatory, but one technology we are using a lot. Mm-hmm. And that's it for this introduction about a generic approach of application development. Now, Stefan, you are working for the Qt company, and Qt are offering a lot of tools and facilities to develop a new project, a new application. Can you say more about that?
Yes, sure. Thank you, Pierre, for handing over to me. As Pierre already demonstrated, you have to take a lot of informed decisions when it comes to your operating system foundation. So that's a tricky subject, a complex subject, and you have to think about it really well. So what do we offer there, or what does Qt have to contribute in this environment? So when it comes to integrating Qt on Yocto or in Yocto ecosystems, we of course provide the Meta Qt 6 layers. Those are meta layers for Open Embedded and Yocto, and those are basically providing recipes for the Qt framework, how it's built, as well as the Squish UI testing framework that we also provide. It also includes an SDK recipe or an example SDK recipe called Meta Toolchain Qt 6. As a comment, I didn't add anything now, but I have it in my notes, so that's okay. So I will explain SDK there. But you're also, of course, able to configure the integrated Qt models. You have, of course, full control of which modules or Qt modules are actually deployed in the end. And you're also, of course, able to integrate our commercial-only releases as well as add-ons. Another more straightforward offering that we offer in this regard is ButoQt, which is a lightweight Qt-optimized full software stack for embedded Linux. So what we provide in this offering is basically an embedded Linux image for a certain type of reference hardware. A cross-compilation toolchain as well that also integrates in all our tooling, namely Qt Creator and the Design Studio. These images are based on Yocto. They use the embedded Linux kernel built with Pokey. And they're, as I mentioned earlier, they're available for a variety of platforms. The first that come to mind are, of course, boards from NVIDIA, NXP, as well as TI. But there are a lot more different platforms available out of box. But yeah, even if your platform is not supported, you are able to create your own custom ButoQt image. And then you are able to use this offering in conjunction with your desired hardware or platform. We also, of course, offer tooling or integrations when it comes to deployment. It's a really important part of the whole process. So when it comes to deployment, we may have to differentiate into two approaches here. If you have your own custom Yocto build already in place, and Qt is, of course, integrated in that, it's pretty straightforward. You can create so-called kits in Qt Creator. These are basically group settings that are used for building, running, as well as deployment. And for example, you can just create a kit for your target system with your custom Yocto build included. You are then, of course, able to define all the compilers that you may want to use, flags, the debuggers that you may want to use further ahead, as well as the deployment steps. These are all fully customizable, of course. And in the end, you can also define a so-called device where you give information like, okay, the IP address, how is it connected to your development host, and once everything's set up, you're then able to just one-click deploy to your platform, basically. Another approach is the ButoQt approach. Those are our Primo built Yocto images. There it's pretty straightforward. You basically just download the QBSP from our installer or our download portal. You can install it using our maintenance tool. The kit for this platform, as well as the device, will be automatically created. And then you're basically ready to go and use it in conjunction with Qt Creator and Qt Design Studio. So how do these offerings integrate into our workflow that we provide within our ecosystem? So this is an overview of our end-to-end tooling environment. And if we start on the left-hand side at the design phase, there you can see it can be a designer, a technical artist, or a front-end developer. And those people are then able to leverage the tools they are familiar with. So let's assume they are implementing their designs in Figma. So then the natural next step would be to use the Qt Design Studio bridge in order to export their designs, layouts, assets, or just single components. During this export, QML code will be created. They can then continue to refine their designs and components in Design Studio, and they can refine it with animations, logical states, and interactions between components, of course. they're also able to just deploy their front-end or front-end implementation onto their target device using Boot2Qt. Which is a really nice feature. You can drive really fast iterations, even in the design stage. You can check, okay, do these designs make sense? Is that running properly on the hardware? Is it performant enough? So you can identify a lot of blockers early on. This whole workflow that we are presenting here is basically possible due to the usage of QML. This is a declarative language, which describes the look and the behavior of the UI. Everything that's related to data in your UI should come from a C++ backend, Qt API, your own implementation. What enables this is basically that you have a nice separation of front-end and back-end layer by design. And you also have the right tools at the right stages that we provide. As you can see, in the meantime, in the so-called development stage, people working on the backend can simultaneously integrate front and backend if they need to, and then they're of course able using Boot2Qt and also drive the same fast iteration cycles early on in the product development stage. This can then all be combined, of course, with our QA quality assurance tool offering. First of all, Squish, which is an automated UI testing framework. This can be run directly on the device. In order to be able to run on a device, you need to, of course, cross-compile some processes involved in Squish. And in order to cross-compile that, we can, again, use the toolchain that's already provided by our Boot2Qt images. Same goes with Coco. That's a code coverage analysis tool that gives you analysis with regards to your unit test implementation. Last but not least, there's also Axivion, which is a static code analysis tool and also takes care of architecture verification. So this is, again, the whole intended workflow that we offer within Qt, and all of these offerings combined from one ecosystem are then able to give you a stable and productive foundation for faster time to market as well as high quality products.
Thanks a lot, Stefan, for this detail about how Qt can definitely make this life cycle and the entire development of an application much more easy and with a full integrated software solution. But just few words before we leave. As you understand, so using the good and the appropriate tooling is something that will bring you values and efficiency. Think about the different environments and how you will be able to speed up your development with a proper development environment, how you will secure more in production with cybersecurity robustness and adaptability is really, really important. And that's maybe what we would like you remember when you are before you leave. Think about your environment. Don't try to use only one method. Maybe you will have the build integrated in Yocto for production, but the build integrated with Qt Creator for the application and all the development purpose. So you will use both methodology. Don't hesitate to take time to set up everything properly, avoiding having the dev team doing and redoing some bad stuff every morning to have a setup working. Think about automation for the future. It will bring you values, I promise. And if you have any question, please don't hesitate. On the next slide, so at the Embedded Kit, we are delivering technology that will help you to bring easily an operating system based on Yocto on your hardware. And we pre-integrate Qt as one of our reference framework. We integrate others, but we push Qt as a reference framework for application development. It will enable you cybersecurity, and you have an ecosystem of product around for doing vulnerability management, automated testing, and also device management that are possible with our toolkit.